Hello everyone, we are from Group 9. Today we are going to present our ISAS entitled Implementation of Breadth First Search. My name is Thalia Demetria Fiona Maharani.
My name is Rafly Rachman. We will get into the first chapter of this presentation called Background. Data structures and algorithms are a fundamental part of computer science education. Data structures are a way of collecting and organizing data so that we can work with it more effectively. Data structure and algorithms include algorithm topics that can be divided into graph algorithms, topological sorts, and breadth first search, and more. In this paper, we will talk about breadth first search, or BFS. We are now entering Chapter 2. Firstly, we will get into the definition of algorithm. An algorithm is defined as a step-by-step procedure or method for solving a problem by a computer with a finite number of steps. The algorithm definition step can be branched or repeated depending on the problem for which the algorithm is being developed. According to its formal definition, an algorithm is a finite set of instructions carried out in a specific order to perform a particular task. A well-defined algorithm is not only a set of finite rules that specify a set of operations to solve a particular type of problem, but also has 6 important characteristics. Input. An algorithm has 0 or more inputs, i.e. quantities, which are given to it initially before the algorithm started. Then output. An algorithm has 1 or more outputs, i.e. quantities which have a specified relation to the inputs. Unambiguous. An algorithm should be clear and ambiguous. Each step or phase and its inputs or outputs need to be clear and should lead only to one meaning. Finiteness. An algorithm must be finite. Finiteness in this context means that the algorithm should have a limited number of instructions, i.e., the instructions should be countable. Effectiveness. Algorithms are also generally expected to be effective. In other words, every operation performed by an algorithm should be very basic so that it can be performed accurately and in a finite amount of time in principle. Last but not least, language independent. An algorithm should be language dependent. That is, the instruction can be implemented in any language and return the same result.
Definition of data structure. Data structure are a way of collecting and organizing data so that you can work with it effectively. A data structure is the rendering of a data item from a relationship perspective in order to better organize and store the data item. The data structure is the physical implementation of IDT. For example, the data structure of a customer entity might contains the customer ID, name, address, birth date, balance, and more. Next is data types. Here is the data structure. A data type is a way to classify different data type. So there are 2 data types. One is built-in data structure. Built-in data structure is those data types for which a language has built-in support are known as built-in data types. For example, most of the language provide the following build is also known as the primitive data structure. And the second is derived data type. Derived data type is those data types which are implementation independent as they can be implemented in one or the other way are known as derived data types. These data types are normally built by the combination of primary or built-in data. Derived data types are also known as abstract data structure. For example, is list. List is linked list is a very commonly used linear data structure which consists of group of nodes in sentences. Next, there is tree. Tree is a binary tree is constructed with the hierarchical data structure like the tree presentation of data set for a large family or an organizational structure of a company. Next there is an arrays. Arrays is definite as a set of similar elements, and these elements can be numeric value, symbolic value, combinations of numeric value, and string, or a set of records. Next is stack. Stack is an abstract data type with a bounded capacity. Next is queue. Queue is abstract data type of a linear data structure. Just like a stack data structure, in which the first element is inserted from one end called the rear, also called tail, and the removal of existing element takes place from the other end called as front or called head. Next is graph. Graph construct with graphics, and in other words, if any element of a lower level in the tree data structure link with more than one element at a higher level is referred to by name data graphic structure. Data structure can also be categorized based on the following characteristic. First, there is linear. Linear is the data items are arranged in a linear sequence. Example is array. Number 2 is nonlinear. Nonlinear is the data items are not in sequences. Example, tree and graph. Tree is homogeneous. Homogeneous is all the elements are of same type. Example is array. 4 is non-homogeneous. Non-homogeneous are the elements may or may not be of the same type. Example structures. 5 is static. Static data structure are those whose sizes and structures associated memory location are fixed at compile time. Example array. Next is dynamic. Dynamic structure are those which expand or shrink depending upon the program need and its execution. Example list created using pointers.
We are now in chapter 3. Firstly, we'll get into the definition of breadth-first search. Breadth-first search is a graph traversal algorithm that starts by traversing the graph from the root node and examines all adjacent nodes. There are many ways to traverse a graph, but the most commonly used approach is BFS. This is a recursive algorithm for finding all vertices of a tree or a graph data structure. BFS divides each vertex of the graph into two visited and unvisited categories. Each select a single node in the diagram, then visit all nodes next to the selected node. Here is the algorithm for a breadth-first search. The algorithm efficiently visits and marks all the key nodes in a graph in an accurate breadth-wise fashion. This algorithm selects a single node, initial or source point, in a graph, then visits all the nodes adjacent to the selected node. Remember, BFS accesses these nodes one by one. Once the algorithm visits and marks the starting node, then it moves towards the nearest unvisited nodes and analyzes them. Once visited, all nodes are marked. These iterations continue until all nodes of the graph have been successfully visited and marked. Steps for BFS algorithm. Pick a node and enqueue all its adjacent nodes into a queue. Dequeue a node from the queue, mark it as visited, and enqueue all its adjacent nodes into a queue. Repeat this process until the queue is empty or you beat a goal. The program can be stuck in an infinite loop if a node is revisited and was not marked as visited before. Hence, prevent exploring nodes that are visited by marking them as visited.
Here's the illustration of breadth-first search or BFS. First is this. There is a queue visited A, B, C, D, G. And first step is initialize queue and visited array. Step 2 is enqueue node A into the queue. So we are put an A into the queue. Step 3 is node A is marked as visited and its adjacent nodes B and C are enqueued into the queue. The next step is node B marked as visited and its adjacent nodes D and G are enqueued into the queue. Next step is node C is marked as visited and no node is enqueued because node C has no adjacent nodes. Next, node D is marked as visited and no adjacent nodes are enqueued into the queue because node D has no adjacent nodes. And the last step is node G is added into the visited array and algorithm stop here because G is the required node. Next is application. Breadth first search algorithm has a wide range of application in the real world. Some of them is GPS navigation. GPS navigation is useful to facilitate the search for the nearest location by utilizing the location of the closest coordinate point. Using BFS becomes faster and easier. If the tree is very deep and the solution is depth first lookup or DFS may take a long time, but if we use BFS, it can be faster. GPS navigation system. BFS is used to find the neighboring location from a given search location. BFS is a traversing algorithm where we start traversing from a selected source, not layer-wise, by exploring the neighboring nodes. The data structure used in BFS is a queue and a graph. Algorithm makes sure that every node is visited not more than once. Next is advantage. Advantage number 1 is solution will definitely be found out by BFS if there are some solution. 2. BFS will never get trapped in blind alley, mean unwanted nodes. 3. If there are more than one solution, then it will find solution with minimal steps. 4. A BFS will find the shortest path between the starting point and any other reachable node. A depth first search will not necessarily find the shortest path. 5. Checking graph with departedness. 6. Copying Chinese algorithm. 7. Always find optimal solution. And last is find the closest goal in less time. The last is disadvantage. The disadvantage of BFS is number 1, all of the connected vertices must be stored in memory, so consume more memory. 2, may not find optimal solution to the problem. 3, may get trapped in searching useless path. 4, memory constraints as it stores all the nodes of piston level to go for next level. And last is if solution is far away, then it consumes time. That's all from us. Thank you so much for your attention. Wassalamualaikum warahmatullahi wabarakatuh.